Good day to all. Today we will look into the first video, which is components introduction. Okay, in this video we will look into 5 important areas as an introduction to components. The first one is component-based software development. Okay, before CBSD is around, applications are built monolithically. Okay, monolithic, meaning that the components are not clear or tightly coupled. Okay, and we can say there are no components that exist actually, yeah. Okay, and then from there, with CBSD, okay, so the components are identified and the architecture are built modularly, yeah, modularly, and modularly, and then it is easier for the components to be reused, to be composed, and it is interchangeable, meaning if this component is not used anymore, you can change with a new component. So this is CBSD. And there are component models being used, which are EJB, Enterprise Java Bean, CORBA, and COM, in order to realize this modular based architecture. From here, the distributed systems are introduced. Yeah, so it evolved into a distributed components. Okay, so from just a standalone component, or okay, from there we have a web services, yeah, and also from the microservices. Okay, so this will enhance the flexibility, and also it can scale the application even more because it is distributed in the network. Yeah, so a lot of client can be served with this particular architecture. Okay, so whatever it is, component based software development is to develop a new software based on the existing components. So we have to find or use any existing components to build new software. That is the goal of CBSD. Okay, from here, what is the criteria of CBSD? So these are the 5 criteria of CBSD. Among them is integrated with existing software, meaning that legacy system also needs to work with the components, and you must have a suitable SDLC in order to support your CBSD. Yeah, so we have actually called a model process CBSE, yeah, in order to support CBSD. Yeah, okay, in CBSD, what happened in or the most important things inside is a component. Okay, so in the component, it encapsulates the functionalities, and it has its own access restriction. It communicates, the most important thing, communicate via interface, and it has its own dependencies between other components. So if you see this one, okay, dependencies with another component. So there are many ways to show the dependencies. So we will look into this later. And also, components are context independent, meaning that it doesn't the development of the component are not depend on the context. For example, if you have a component which are related to accounting, yeah. So for example, account payable, general ledger, and also payroll management, yeah, and maybe financial report. Okay, so these 4 things, 4 components. Okay, so it can be, or it has potential to be used in other types of application. For example, human resource application. Yeah, okay, human resource. And then it can be used in e-commerce, of course. It can be used, it has the potential to be used in non-profit organization management, especially in terms of its managing its accounting and so forth. So it's not based on the context. Okay, so in a component, okay, what is inside, or what are the properties of a component? So I just highlight a few. Okay, the most important one is the it's reusable. It's reusable here. Okay, it can be used immediately using its interface. Okay, and another thing which is we have seen, or we have heard it from the first topic that we have learned, which is separation of concern. And here in components, the separation of concern are based on separation of interface from its implementation. Okay, so that is very important of a component. Okay, so let's see about component models. Okay, component models are the one that are helping the components to build an application. Okay, so one of the example of component models are EJB, Enterprise Java Bean. Okay, so we can have other types of components. For example, we can have COM from Microsoft, and also Java Beans. Java Beans also a type of component. Okay, so basically, there are also another terms that you will learn also beside component model, which is framework. Okay, so what is the difference between framework and component models? So basically, component models are a standard or guideline to create component. For example, COM just now, it can be used, or it can be developed using C++, C#, or VB, and it can be used to create components to be used in Windows OS. For example, ActiveX, and so forth. And for the framework, for example, Django is one framework. Django. Okay. Another framework is what else? Laravel. It's another framework. So it is a MVC based, Django MVC based model, and framework also is use with it comes with the libraries and so forth, in order for you, or in order to support you in developing application. So that is a little bit difference between component model and framework. Okay, you can also see this particular video, a very short video, which is very good video, only 30 minutes, on the introduction of EJB. Okay, so let's see next. So we already know about software component, the properties. Okay, and software components conforms to component models. Okay, meaning that it is an element inside a component model. So it can be deployed and composed. Okay, so component models also can conform to a framework. Okay, so if we see here, component model have standards in order for you to implement, to name, to customize, and so forth, or deploy your components, application based component, or component based application, sorry. Okay, and also component model, one of the important things about component model is it can be independently deployed. Yeah. Okay. Meaning that it doesn't, if you choose these particular components, maybe 5 components, so the components doesn't dependent on others. So it can be deployed, the 5 components can be deployed by itself. Yeah. Okay. And then it is reusable, and it can increase time to market. Okay. So of course it is can be, the component can be developed for use, okay, or from reuse. So meaning that you can develop your own component, or you can reuse component existing off the shelf, or maybe web services or other components. Okay. And also, like what I've said earlier, for component-based development, it has its own SDLC process model, which is one of it is you can known it as a CBSE, component-based software engineering. It's one of the term. Okay, so when you develop using component, actually you cannot fulfill a lot of requirements because your components are maybe limited on that particular requirements only. So then maybe you have to develop for use other components. Okay, so that is a little bit different from the other model, process model. Okay, other than that, you have to package the component so that it can be deployed independently. Okay, and it should be in the form of executable code, meaning that in the form of raw, okay, EXE maybe, and so forth. Okay, so now how to model? Okay, how to model the component? So there are many annotations exist. Many annotation exist. So it can be either using this lollipop and fork. Okay, so lollipop is the provided and this is the required. Okay, depending on what type of tool that you are using, so it can be like this or like this. Okay, so when you want to show all the provided and required interface in your component, so you can use the lollipop and fork independent like this. So meaning that this particular order process offers interface that can be reused by others, which is order entry, and order process cannot do payment, so it requires interface from other component, which is interface payment. Okay, that is how to understand the diagram. So if you are required to draw only one component, you can use this one. You can use this particular annotation. Okay, so there are other ways to show the components, to show the modeling of the components. Another way is when you have two components, which is the components you already identified can provided you with the interface. So this is what we call as required component uses provided component. So the required components already given by the provided, I can say that the required component interface have already got its own provided interface. So which is basic alarm service offers the interface of iBasic alarm service, which can be used in the operation interaction. Operator interaction, sorry. Okay, so when you have more than one components, you can show it like this, meaning that the components already can be integrated together. So these are the interfaces that can integrate these two components together. They have dependency, right? Okay. okay, together. Okay, meaning that student module offers read-only interface which are required by MARC database, the same as happening here. Yeah, okay. And also you can see here you can also show what's inside your interface, meaning what methods inside your interface which have to be implemented by other components if the components required that particular interface. Yeah, so that is how you model. Okay, if it's only one, or if it's more than one, to show the integration between the components. Right? Okay, so we come to the separation of interface from its component. Okay, so we can say interface and component implementation should be completely separated. Yeah, just like this one. Yeah, completely separated. You cannot show how the interface are implemented here. Yeah, okay. And also you can see from this diagram also the interface are restricted to the communication between the components are restricted only by using interface. Yeah, that is the criteria of components. Okay, only using interface to communicate. Okay, it cannot it cannot inherit. Okay, it cannot inherit, it cannot aggregate and so forth. It can only communicate via interface, meaning that you have to implement the interface provided. Okay, so that is what I can relate to you about separation of interface and implementation. Okay, so from this particular diagram, you can see a direct and indirect interface. Okay, direct interface is what is actually provided by the component. Okay, this one is the direct one. Direct one. Okay, and we can say indirect one is the component that provides an interface to the internal objects. Yeah, so that is direct and indirect. Okay, so only the object inside it realize the interface. This is indirect, this is direct. Okay, but the most important thing is how you model your components. So make sure you know to model one only or to model more than one. Okay, so as a summary, components are like Lego pieces, and you can put them or integrate them together using the interface. Okay, and you can use a component model as a guidance on how to fit the components together, creating it, composing it, and also deploying it. So component model really guides you in terms of that. And like what I've said before, interface is the only way for the components, for the different component to communicate to each other. Okay, so that's are the important pointers for this video. Okay, that's all, and we meet again in the next video on manage components.